Hi guys, let us go ahead and do a binomial experiment example. In this case, we have n, which is the sample size equals 10, and we have p, which is the probability of success in any one trial of 0.1. We want to compute, first of all, f of 0, so let's start there. So here we see the binomial formula, and you're going to want to understand how to find these, how to use this formula to find the numbers. So you're going to plug n in wherever you see n, plug x in where you see x, and then you're going to multiply by p raised to the power of x times 1 minus p to the power of n minus x. So this should be n minus x. Let me change that. N minus x. So f of 0 is equal to 10c0, and this c means the combination. So you're going to do this combination on your calculator, and then you can see that 10c0 is 1. So again, the way to do that on your calculator is to use the function called ncr to find, and you should be getting 1. Then you want to do 0.1 raised to the power of x, which in this case is 0, so we raise it to the power of 0, times 1 minus p, which is 0.9, raised to the power of n minus x, which is 10 minus 0. So we're going to get a 1 times another 1. Anything raised to the power of 0 is 1. And then times 0.9 raised to the power of 10. When we put everything together, we multiply, we get 0.34868. If you want to simplify this, you could do 2 decimal places to get 0.35 as your answer. Next, we want to find f of 2. Again, just like before, we plug in the values for n, p, and x. N was 10, so 10cx, which is 2, times p, 0.1 raised to the power of x, which is 2, times 1 minus p, which is 0.9, raised to the power of n minus x, which is 10 minus 2, which is 8. And so 45 is 10c2, 0.1 squared is 0.01, times 0.9 to the power of 8, which is 0.43047. And to raise something to the power, to a power on your calculator, usually you would do something like this. So look on your calculator for a function that looks like this. 0.9, and then you're gonna press y to the power of x, and then you type the 8, and you should get this value. So every calculator might be different, so double check your calculator what this function is. And when we do this multiplication, we get 0.19371. In number 3, we have to do the probability that x is less than or equal to 2. And so let's do that one. In this case, this is how we write it out. If we have a discrete random variable, which is what the x is in this case, that means we're not interested in the 1.5 or 0.5 in terms of the value of x. It's going to be discrete numbers, meaning 0, 1, 2. So how many ways can x be less than or equal to 2? Only 3 ways. It's either going to be 2 because it's equality, or it can be 1, which is less than 2, or 0, which is also less than 2. And so these are the 3 options we have. So we need to find each one. We already have f of 0 from before, and we just did f of 2. So we need to still find f of 1, then we're going to add everything together. So here we have f of 1. So 10c1, 0.1 to the power of 1, 0.9 to the power of 9, and then we multiply to get this value. Then we put everything together, so f of 0 plus f of 1 plus f of 2, and our final answer is 0.92981. We can simplify that to 0.93 to 2 decimal places. Here again is a reminder of what we're trying to find. So far we've done number 1, 2, and 3. Let's go to number 4. In number 4, we have to find the mean of x, which is the same thing as the expected value of x. And the formula for the mean in the binomial case is just n times p. And so we're going to take the sample size times the probability of success in any one failure. So this is 10 times 0.1, which is 1. Then we get to the variance of x, and this is sigma squared. It's equal to n times p times q. So these are always going to be the case for the binomial. These are preset formulas. So n times p, and q happens to be 1 minus p. So it's going to be 0.9. So we're going to have 10 times 0.1 times 0.9, and our final answer is 0.9 for the variance. And finally, for the standard deviation of x, is the square root of the variance of x. So it's the square root of 0.9, which is 0.94868, or to simplify, it's 0.95 to 2 decimal places.